Hello and welcome back to WySLICE. We've had a look at Conway's Game of Life before, and I kind of made you do this tedious exercise of stepping through something manually. But apart from that, you might be wondering, well, how is all of this really related to computer science and programming? Well, you can actually think of you specifying the pattern that you want the Game of Life to run as programming a computer. Let's have a look at this together. So what I'm doing in this Game of Life here, let me make this pattern slightly more interesting, is I am specifying a start state, and then I'm clicking start, and the computer does the rest. So I'm doing some kind of simulation here determined by the rules of Conway's Game of Life, and looks like I happen to hit upon a relatively interesting pattern that involves in very nice ways until eventually it stops here. That's exactly what we're doing when we're programming a computer, right? We're specifying something for the computer to do and some data to operate on. The difference is really just that here for Conway's Game of Life, we're not specifying what to do exactly because the rules are set. And I refer you again to the explanation here if you need a reminder on that. So that we're not influencing at all. The only thing we're doing is, let me reset that to its initial state here, is specifying the data that we are operating on. And in that respect, it's pretty much the same as running a computer program, right? You're not doing the actual programming, but you are specifying input data of some type. Of course, this is not going to be live cells in a grid here or pixels if you want to think about them that way, but it's going to be some other kind of input, like, you're typing a document, for example. So you're providing input for your word processor, which then does certain things with it, depending on the rules that were programmed into it. Exactly the same thing that happens here. Now, in this particular context, we can think about these patterns here as building blocks, or in kind of computer programming terms, as functions, because these determine what's going to happen with the pattern when we press the start button and when we start the simulation. Here I only have one. I can have more than one. Let's see what happens if I specify another initial thing that looks exactly the same. So I'm just replicating this building block here. Okay, and okay, that wasn't quite as exciting as we had before. As we discussed before, even relatively small changes to the initial pattern in Conway's Game of Life can have quite a large effect. So in this case here, we went from a really quite interesting pattern that took a couple of iterations to produce interesting intermediate patterns until settling into a stable state, to something that really wasn't very interesting at all. Okay, of course, we don't need to stop here. I can specify another one of these functions. I can specify another one of these building blocks. So we can essentially combine these in arbitrary fashion. Okay, let's try these three stripes here, see what happens. Well, that's not particularly exciting either. Well, at least it worked a little bit better than before. Let me combine this with another possible pattern, and I'm just going to make something up here, and excuse me, maybe this pattern here on this other side. So now I have essentially three different kinds of building blocks, or three different kinds of functions, again, if we want to think about this in terms of programming, that I have combined in this particular way. I'm going to start this and see the result of my simulation. Okay, also not very exciting. Let me clear this, because of course I can do this with much simpler things as well. So let's say I have a pattern that is this cross of 5 pixels, and I'm now going to distribute a bunch of these across my grid and see what happens. So this idea of having several individual building blocks that I can combine in arbitrary ways, that's what I'm doing here. That's what I'm experimenting with, much in the same way that back for one of the previous activities, you did this in a kind of less principled manner where you didn't necessarily think about individual building blocks or functions, but just what is it that determines an interesting simulation, and try to come up with ways of making something more interesting. So let me try one last initial pattern here. There we go. That's what I want you to do in this activity. Think of the patterns that you have played around with before. For example, the glider that we have talked about as a building block or a function, and now try to come up with interesting ways of combining these. In particular, for the glider, there are a bunch of different things that you could do there. You could have two gliders that move towards each other and then kind of crash into each other, or you could move two side by side or something along those lines. So play around with this, and while you're doing this, try to think of the different building blocks, the different fundamental building blocks that there are, and how you can combine these into more interesting patterns, and in particular, what happens when you combine these. So coming back to the question that we tackled in the previous activity of how do we get interesting behavior in our simulations, really quite difficult, right? Maybe that's a way to make it easier in practice by essentially saying that, well, we have this particular building block and we need at least 3 of these building blocks arranged in a particular way to get an interesting pattern. So have a go at this and try to experiment with this a little bit.